Hello and welcome. Today we have a really interesting problem. We have a right triangle and we have inscribed a circle in it, like this, such that the length of this side is 2 unit and the length of this side is 5 unit. We need to find the area of this right triangle using this information. At first, this looks complicated, but wait till the end, because I'll show you a trick that lets you solve it in just a second. So, can you solve it? First, I will demonstrate the classical method for solving this problem, and afterwards I will present a quick trick that allows us to solve it in just 1 second. As a first step, we will generalize the problem by denoting this segment as m and the other segment as n. Next, we denote the radius of the circle as r. Now, we apply an important result, the Two Tangents Theorem. It states that if two tangents are drawn to a circle from a common external point, then the tangents are always equal in length. Considering this vertex of the triangle, we see that these two line segments serve as tangents to the circle, correct? Therefore, the length of this segment will be equal to the length of the other segment, which means it is also equal to n. Similarly, if we consider this vertex of the triangle, the two line segments from this point act as tangents to the circle. Hence, the length of this segment will be equal to the corresponding segment, which is also equal to m. Now, let us consider the tangent radius theorem. A tangent is defined as a straight line that touches a circle at exactly one point without intersecting it. An important property of a tangent is that it is always perpendicular to the radius drawn to the point of contact. Therefore, if we draw a radius to the circle at this point, it will be perpendicular to the corresponding side of the triangle, since that side acts as a tangent to the circle. Similarly, if we draw another radius to the point of tangency, it will also form a degree angle with the tangent. This is remarkable because both of these angles are degree, and this angle here is also degree. Hence, the remaining angle must also be a right angle. Moreover, the quadrilateral formed has both its length and width equal to r. Therefore, this quadrilateral is in fact a square with side length r. Consequently, each of its sides is equal to r. Do you also notice the same relationship? The length of this leg of the triangle is m plus r, while the length of the other leg is n plus r. Furthermore, the hypotenuse has length m plus n. Since this is a right triangle, its area can be expressed as 1 over half the product of its two legs, that is, 1 over 2 into m plus r into n plus r. Now, let us expand this expression. Multiplying out, we obtain r times r equal r square, r times n equal rn, r times m equal rm, and m times n equal mn. So, what should we do next? We have not yet used our most powerful tool, the Pythagoras theorem. Since this is a right triangle, we apply it as follows. r plus m whole square plus r plus n whole square equal m plus n whole square. Now, let us expand each term step by step. r plus m whole square equal r square plus 2mr plus m square. r plus n whole square equals r square plus 2nr plus n square. m plus n whole square equals p square plus 2mn plus n square. Now, by combining the terms, we obtain r square plus 2mr plus m square plus r square plus 2nr plus n square equal m square plus 2mn plus n square. Notice that m square and n square cancel out from both sides, leaving us with 2r square plus 2mr plus 2nr equal 2mn. Now, we dividing it by 2, and it gives us r square plus mr plus nr equal mq. Finally, factoring out r from the middle terms, and we obtain r square plus r into m plus n equals mn. Now, let us proceed further. If we add mn to both sides of the equation, we obtain r squared plus m plus n into r plus mn equal mn plus mn. And it becomes 2mn. Notice something remarkable here. The left-hand side is exactly the same as our earlier expression for twice the area of the triangle. Therefore, the area of the right triangle is simply mn. This is the key insight. We do not need to find the sides or the radius at all. The area is simply the product of the two tangent segments. Now, applying this trick to our problem with m equal 2 and n equal 5, we find the area to be 2 multiply 5 equal 10 square units. And that is our required result. I hope you find it helpful and enjoy it. If you did, please give this video a like and subscribe to our channel for more problem-solving strategies. Thanks for watching, and see you in the next one. Good luck.